All right, we're going to start working on our Chapter 4 exercises, and just a reminder, the programming exercises, which are the ones that I assign, are the ones that start with the letter P. I still seem to get some people are confused about that, because there are also the review exercises in the book, which start with the letter R, and those are valuable to do too, but I don't assign them to you, so just so you know, but those are really good review. But we are going to do the programming exercises, and the other thing I should tell you is that whenever I post them in the course shell, I've been trying to also, oh, you guys can't see this yet, well, I got to make that available, and that is, I try to also add a document to each assignment listing, just in case you don't have your book nearby. And since you guys are watching me do this, I'm going to show you how I edit my assignment postings here. And add that document in. And I don't know how many of you are like so ambitious that maybe you go above and beyond what's assigned to you. If you're really that kind of ambitious because you just really want to learn this so much and you just love programming, remember I always have extra credit assignments that are attached as well. And so I'm going to just drag and drop my exercise file over. And that's just going to upload I create a document each week with all the exercises, and it is attached. All right, so we're going to start with 4.1, and 4.1 reads as follows. It says, write programs with loops that compute the sum of all even numbers between 2 and 100 inclusive, the sum of all squares between 1 and 100, the powers of 2, the sum of all odd numbers, I'm just abbreviating now, and the sum of all odd digits of an input. Okay, so we're going to go through each one of these, and there's 5 parts to each exercise. Now it seems like a lot, but you know what? Once you get the logic of it, it all goes pretty quick. Did I give you guys the hint that a lot of this stuff we already saw before, and we can kind of borrow from it? Okay, so, and you know, you got the other advantage is I'm helping you do your homework. Are you guys catching that too?
Yes.
Okay. All right, so the point here is to learn it, not to be punished in the process of learning it. All right, so I'm going to get my all my tools ready here, and I'm just kind of arranging my screen. So I do have my Spider IDE is up and running. I have my file folder open where I'm going to save my work, or do I? Let's go ahead and make sure that I have a folder created. So let me bring that back over to the screen. And I store all my stuff in my Google Drive. And in my Python folder. And then in fall. And then I'm going to create a new folder called Chapter 4 for this work. All right, so now that I have a chapter to work with here, let's go back over to the IDE. And I do have a file open here, but I'm going to create a new one. And notice this, if I close all my tabs, you see what Spider does? It just creates a new file for me. Isn't that nice? Very, very nice. All right, I'm going to go ahead and do a save as right off the bat. And I'm going to make sure it goes into the correct folder. And this is exercise 4.1. And I'm not sure if it has any sort of text indicator that goes with it. No, I'm just going to call it exercise 4.1. I think that's enough. .py. And save it. All right, so the first step that we have to complete here is figuring out how we're going to structure all this. And I kind of actually see this as 5 separate programs, by the way. Could you write it all inside of one program? Sure. But you know what? Now that I know that, I'm going to rename I'm going to do another save as. And actually I'm going to call it exercise 4.1a. Like that. All right, so the first one, somebody read to me the instructions for the first one.
Write program with loops that compute the sum of all even numbers between 2 and 100.
Okay. And I'm just copying from the author here. Here's what he put in his comments. It says, use a loop to sum the even numbers from 2 to 100 inclusive. What does that mean? Include 2 and include 100.
Oh,
Okay, and we want the sum. Now, if you want to make sure of what the value of this is, you could be like a total geek, right? And you can go to a calculator and go 2 plus 4 plus 8 all the way up to 100. Or if you were more efficient like me, you'd go to a spreadsheet, type 2, 4, 6, 8, highlight it, drag down, take it all the way up to 100, highlight the whole thing, and you get the answer. So you know what the right answer is, and that's actually kind of important, honestly, that you know what the right answer is. So as silly as it is, I'm actually going to bring Excel up on the screen. You can do this with Google Sheets too if you want, but I'm just showing you that as a programmer, you just can't take it for granted that the math that's happening in the background is right. So I'm just going to create a blank workbook here, and I'm going to do exactly what I said. I'm just going to go 2, 4, 6, 8, and that's enough. It gets the pattern after a while, and if I highlight that pattern in Excel, and then I just drag, I keep dragging, and notice how there's a little box that shows where I'm at right now. Wait, I just want to go up to 100, right? Okay, so it does it all the way up to 100. All of that is highlighted, correct? It's all highlighted. And what Excel does automatically is when you highlight a bunch of numbers, it tells you what the sum is. What does it say down here? It says 2550. There's 50 values. It tells me the count. Notice at the bottom it says the average, the count, and the sum. This tells you right away, folks, these are such common functions. Excel just has it built right in whenever you highlight something. I think that's kind of interesting. So they have code running in the background that automatically does the things that we're about to do. Right, so you guys are creating a spreadsheet program, basically. All right. But that's the value that we're looking for. So we know that in advance, so then if we come up with a value that's off, we know. We know that it's off and why it's off, because we did something wrong. All right, so I'm going to start by creating a variable that's going to hold the total. Okay? Because we're going to have to create a sum, and I'm going to preset it to 0, because that kind of makes sense. Now, the first question you should ask yourself is this. Which loop structure should I use? Could I use either one? Absolutely. Is there one that would be better for this task than another? Absolutely. The answer really is for loop for this, for a number of different reasons. Let me explain as I type it in. So I'm going to start by just clearing the for loop. I'm going to use I as my index value or my counter variable kind of thing. And I'm going to say in range, and here's where the challenge comes in. What do I type inside the parentheses?
2, 100.
Right, absolutely. The range is 2 to 100, because it says right up above from the comment, right? And then we're going to go even numbers, right?
Yes.
So I will count by 2. See how easy that is? And that's why a programmer would jump in and use a for loop, because I don't have to write any other code. It goes sum equals 2 plus total. You don't have to do that. It just does it automatically. That's the beauty here. We do, like with an if statement, we do need to put in the colon to say, go ahead and do this, basically. And then we will indent one line. And every time the loop runs, we're going to take whatever number we're on currently, that's what the I is, and we're going to add to it whatever I is. So if you conceptualize this, like if I was to hand trace it, like do the thing, total would start at 0, I would start at 2. The first time through, total becomes 2, 2, and I is 2. The second time through, it becomes 4.
Total is 4, I is 2. Right?
Yeah.
And then 6 to 8.
Exactly. And see, that's the other nice thing about a spreadsheet. Like if you actually wanted to figure it out, like hand trace it, spreadsheet's a great tool to do it. You can say total, and you can say I. So when total starts out at 0, and I is 2, and then the loop runs, and the total becomes 2, and then I becomes Yeah, see, it's kind of a little, yeah, the real trick to this is total is set before we go into the loop, right? And so the second time through, I is, yeah, and maybe I would be more logical to put first, right, and it would happen like this. So this one, this column here is really just this, right, just like the even numbers. And then, could you write an Excel formula to calculate it all out for you? You totally could. Right, okay. So I'm just showing you that as an example. Now all we have left to do is put the stuff on the screen. So let's just do a print statement. And you can type in whatever you want. You can say the total of the even numbers from 2 to 100 is, and then just type in the total. And actually, comma total. So I'm going to go ahead and hit run, you guys. Okay, we got a problem. You guys catching this?
On the Excel, it says 25K.
You got it.
So we're down.
Yeah. Do you guys remember the stipulation for running the range? See, now you're catching how this works.
Wait, what did you say?
Yeah, so notice I ran the program, and the total I got here was 2450. But I know, because I'm smart enough to use Excel and to validate my values, that if I highlight all these, what it really should be, oops, one more, is 2550. You guys should all go, huh? Right? You all should do that collectively. And if you notice right here in Excel, the count says 50. I know people over here aren't seeing the board too well. But way down here in the bottom of Excel, in the bottom corner, you can probably see it better on one of those screens, it gives me the average, the count, and the sum. And it says I have a total of 50 values, which means the last value for 50, how do we fix it then?
Do we have to change the 100? I'm going to say
Because if
that would be wrong. Will we change it to 102?
101.
Oh, okay.
Well, you know what? Or 102. But I'm going to set it to 101.
Sure.
Because I never wanted to get to 102. That's my way of ensuring it.
Yeah.
All right, so let's run it one more time. And there it is. Isn't that interesting? All right. So that shows you how range works pretty well. We got the first one, piece of cake. Next one, you guys ready? All right. Let's do another one. New file. Save as. Exercise 4.1b dot pi. Okay, the instructions on this one are as follows. The sum of all squares between 1 and 100 inclusive. Okay, so I'm going to copy that over to Spider. I'm going to just put a pound sign in front of it, paste it in. All right. Could we just borrow from what we just did? Totally. We totally can. I'm going to just go ahead and type it because, you know, it's not really that much code. So we're going to start with a total. We're going to preset it to 0. All right. Start with a total of 0 one more time. We're going to use the same technique. I'm going to use the for loop again. All right. This time I'm going to say, this time we're getting generate the squares. Yeah, this is, well, I got to think about this one. But we're going to get the squares of all the numbers from 1 to 100. So I know that I'm just going to do like, I'm probably going to do the range thing again. And I learned my lesson last time. If I'm going from 1 to 100, I'm going to type 1 to 101. All right, so we got that problem squared away. No math joke intended there, by the way. So if we're going to figure out the total of all the squares, every time through, we're going to add the total back to itself and then add the squares. How do you square a number?
Asterisk.
Yeah, you could go I that like that, right?
Do that. Oh.
Which is equivalent to just saying I times I, isn't it? Either one is correct. You guys catch that? And just so you guys understand, I'm going to say or I asterisk asterisk 2. Same difference. Either one is right. All right? And then we're just going to print again. So I'm going to do print. And you know what? I don't want to type all that, so I'm just going to copy from here. Print. Now here's the thing. Could I somehow double check my answer in Excel? I could. So if I was in Excel, now you guys are all panicking because I'm leaving the screen, right? So once again, I'm going to go, this time I'm doing all the numbers, right? So I would go 1, 2, 3, 4. I got a pattern going, right? In Excel, thank you very much. I can just do this and then drag down. This time I'm going to go a lot farther. Oop, way too far. Okay, there's 100. And then in the next cell over, I can do a little sum, or actually product, right? I can actually just say K, what is that, K2 times K2, that's a square, right? And then all I have to do is drag the formula down. 2 squared is 4, 3 squared is 9, that's all right, right? So then I can just drag that all the way down. There's all my squares. They're all highlighted right now, right? My sum is 338,350. Got that? All right. It's in my brain. But see, this is my double check, right? And as a programmer, you got to do double checks, folks. You can't just assume your code's right. All right. So back over to the code. I have my formulas in. This should output, I'm hoping, the right number. Let's go ahead and do the run. Is that the right number? 338,350? Bingo. We're good. But you see how I double checked it? I know it's the right answer. So will I like kill you on your grade if this is like, 338,000, 549? Well, it indicates to me that you're not getting the right answer. Your code's off somehow, right? Does that mean you're a complete idiot? No, it means you probably just need to adjust one little thing. I mean, that's all it is, right? So with the first problem, we were off by 100 just because we didn't run the loop one more time, right? That doesn't mean you're like, all your points are gone. I just want to let you know that. It means you're close. It's like horseshoes and hand grenades, close sometimes counts. I still like you to get the precise answer because it shows me that you're paying attention, or you're concerned. Okay. All right, so that was, which one? That was B. All right, so now we're going to do another new program. Save as. Exercise 4.1 part C. .py. And let's get the instructions from the book.
All powers of 2 from 2 to 0 up to 2 to 1.
Okay. All the powers of 2, paste it in as a comment here, from all the powers of 2 from 20 up to 220. Now I got to make sure I'm reading that right. Right? All the powers of 2 from 20. All right. So I gotta think about this really carefully.
Would it be different? Is it 20? In the book it says 2 to 0.
2, oh yeah, well it says, thank you for checking that, because I was like, that makes no sense to me. So 2 to the 0 power up to 2 to the 20th power. Now I want you to write programs that compute, all right, that computes. It doesn't ask me to get the sum this time. I don't have to do a total. All right, that gives me an idea. They just want me to print out what they are. Aha. All right. Now watch what I do here, folks, because this is kind of interesting. So I can bypass the totaling, which means I can go right to my loop. So I'm going to say I in range, and I'm going to start with, what should I start with? All the powers of 2. And so 2 to the 0. So I'm not changing the 2 each time. See what's happening? I'm changing the power.
Yeah.
So I'm going to go from what to what?
0.
You're going to start at 0 because they want us to start with the 0 power up to the 20th power, which means my range is 0 to 21. Very good. Very good. All right. And since I don't have to store anything, I'm going to go directly to a print statement. This is kind of an interesting approach. So I'm going to say, I'm going to do it like this. 2 star star, right, in Python speak. I can't really do exponents in plain text. I'm going to output I. You guys see where I'm going with this? I'm going to output the power. And then I'm going to say is. Then I'll actually do the math. I'm going to do 2 star star I, like that. That'll do the whole thing. So the 2 to whatever I is, the power, is whatever the result of the math is. This is a very simple program. That's pretty dope that it's.
I see why you put the 2 star star as a string first.
Yeah, that's good. That's what the user's going to see.
Yeah.
Right. And what I could do is like 2 to the 8 power. I could do that too. So I could,
Right.
Should I do that? Nah, that's too much work. I want to make this efficient.
Work smarter, not harder.
Could I validate that inside of Excel? I'm just taking it at faith that this is right. You know how you could validate it? You could actually do a calculator program, right? Just bring up your calculator. And if I want to put something to a power, well, it doesn't, how do I do that? I can't do that here, can I? Now you actually kind of have to do that in Excel. All right. I'm taking it at faith though because I want to move on. You guys good with that? All right. New file. Save as. Exercise 4.1D, right? .py. All right, let's see what they want us to do this time. The sum of all odd numbers between A and B inclusive where A and B are inputs. So we get to let the user choose. Isn't that interesting? We're going to have 2 inputs. Are we going to let them, and actually we got to read those, the sum of all odd numbers between whatever the user put in, where A and B are inputs. We got a couple little challenges here. Well, let's do the inputs. Inputs are a piece of cake. So let's do this. We want to make sure that they give us integers for one thing, right? So let's do that. So I'm just grabbing 2 inputs, enter an integer, enter another integer, store them in A and B. All right. Now what we have to figure out is if the first number Okay, well, we know like what the algorithm is. We say the sum of all odd numbers between whatever the user gives us. But here's our challenge. Before I can run any sort of loop, I got to check to see if these are odd or even. Uh-oh. How do I do that? Magic crystal ball computer.
Modulate.
Yeah, you could do a modulus, right? You could do mod. You divide any number by 2. But if you do the mod version, if there's a remainder, the remainder is either going to be 0 or 1. If it's 0, it's even. If it's 1, it's odd. See? Very, very simple logic.
Computer only look at basically 2, the 0 or the 1.
Right. And then I'm going to throw in this little caveat here, and you guys, you don't have to type this in, but I'm putting it up on screen because it makes sense to me. It says, if A is even, then the first number we want to include in the total is A plus 1. Got that? Right? If A is odd, then the first number we want to include in the total is A. So that's the logic here. So then we have to write an if statement that does exactly that. So let's drop in this if statement. And yes, I'm copy pasting because I want to be efficient here with time. So we're checking. If A mod 2 is equal to 0, then it's even. But we need it to be odd, so we add 1 to it. That's the logic we just stated there. Otherwise, we just leave it alone. Right? But we are storing it in a different variable for passing on to the loop. Right. The next thing that we're going to do is we're going to use the loop to generate the odd numbers just using its automatic mechanisms that it has, right? So I put in this little logic thing here. Use a loop to generate the odd numbers from A to B inclusive, adding each to the total. Uh-oh, that means we need a total again, right? So we better start by declaring a total variable. Let's say total, let's pre-initialize it to 0. From there, we build our loop. So we're going to stick with the I thing. We're going to say I in range. And what are we going to start with?
0.
No. The first number the user entered, either adjusted with the extra 1 or not. So the first value is first known. Okay. Now here's where the thinking cap comes on. I know that whatever I do in the middle, right, I'm going to count up by odds. So I know that once I have the first number in there and it's odd, I know I'm going to go count by 2 each time. Well, what goes in the second position? The first position is the starting number. The second position is the ending number. And we've learned the hard way that we usually have to add 1 to it to make it work. So whatever B is, it's going to be B plus 1 here. You guys seeing my logic? Put in the first number and the last number. We add 1 to it to make sure it gets included in the range. Whether it's positive or whether it's odd or even, really doesn't matter. Okay? Once we have that in place, then we can actually do the stuff in the loop, which is basically just to add that number to the total, right? So total equals total plus 1, or excuse me, plus I. You know, and I probably should be nice and format this a little cleaner like that. All right, folks. Last thing we need to do is put it up on the screen. And I have a pre-prepared print statement here to just drop in. So I'm going to say print the total of the odd numbers from A to B, whatever the user originally entered, is total, which was calculated. now that we've kind of figured out how Python works and handles these things, we should kind of be okay. So I'm doing a save, and I'm doing a run. So enter an integer. I'm going to keep this really simple for right now. I'm going to kind of mess it up. I'm going to put in an even number to start, 2. Enter another integer. Let's do 10. Now I could figure this out in advance. So let's see. Some of the odd numbers. So what's the first number? 3. 5.
7 and 9.
Yeah. So 3 plus 5 is 8. 5 plus 7 is... What is that? Yeah, see, now you're doing exactly what... Yeah. Right. So how do you figure out what the right value is? You set up a spreadsheet, folks. That's how you figure out the right value. I'm taking this on faith that it's right. Because my coding is so good, I'm taking it on faith. And I'm going to tell you what, for a real world application, if this is the program that lands the man on the moon, you're not taking it on faith.
Yeah.
You know, you're gonna make sure those calculations are correct. You're gonna validate it like 20 different ways. I mean, I'm seriously, right? Right. So, oops, wrong planet. You know, that's not the situation you want. All right, we got one more part in the first exercise here, so we're going to move on to exercise 4.1d. I'm trying to move as slow as I can. All right, so the next one's going to be the sum of all odd digits of an input. For example, if the input is 32,677, the sum would be 3 plus 7 plus 7 equals 17. So we only look at the odd digits of that number and add them together. Ooh, that sounds like a challenge, right? Not so bad, really. Let's take a look and break it down. Start first by creating a new program. Do your save as. Exercise 4.1 part E dot pi. I'm going to paste that in as a comment so we have it as an example. And let's start writing the solution. All right. We do need to keep a total here, right? Because it says the sum. So I'm going to start by creating a total variable. And you know, you could call this sum, you could call it whatever you want. Total makes sense to me. I guess sum would make maybe more sense, but total it is. All right. Now, we have to figure out a way to extract each individual number from the whole string of numbers that's going to be given. Wait, where are we getting the number from? Oh yeah, we need some user input. You know what, let's do that before we do a total. How about we say digits equals input. I'm going to say enter an integer. Colon, space, like that. Why am I not converting that to a number?
Parse it.
Right, because I want to be able to step through each character. You can only do that with a string, and convert each character separately to a number.
And figuring out what the third letter is, you know.
Yeah. And so if you want to, from a logic standpoint, here's the action that we're going to take. Check each character in the string. Begin by converting it to an integer. If it is an odd digit, then add it to the total. Pretty simple. Okay? Now, sometimes you might not see the logic of this stuff right off the bat, and that's okay when you're starting out. But we have these beautiful built-in capabilities with Python, so I'm going to be able to check the character, the CH, that's what I'm calling it, in digits. That's a predetermined structure. right? It's a string, right? But it's a structure, so we're going to step through each character in digits. And every time we do that, we're going to set up, well, we need a number variable to hold the number, so we're going to set up a variable called n, and that's just going to take and convert each character individually to a number, just like that. Then we need to check if it's even or odd. Well, we know this logic already. So we can just say if n mod 2, how do we check if it's odd? What would the remainder be? If I divide any number by 2 and the remainder is 0, then it's even. If I divide any number by 2 and the remainder is 1, then it's odd. Okay, so when I do a mod, it just looks at the remainder. So any number divide by 2, what's the remainder? If it's equivalent to 1, then it's odd. And it's only in that circumstance that we do the math. So we're going to say total equals total plus whatever the number is. All right. Believe it or not, we have everything we need already. We're done. If you want it to be really particular about this, and I know I get this, I'll get a group of students that are this way, they will go through and do an output. Every time they do this, right, they might also add in a statement that says print n is this, 3. 3 is odd. Since it is odd, add to the total. Here's the new total. And they'll do like the whole thing. So they'll put print statements in here to detail it all. And that's up to you. You want to do that, you go ahead. It didn't ask for us to do that, so I'm just going right to the total. So I'm going to save this and run it. Enter an integer. And remember, they want us to add like something kind of long, like this. How many odd numbers do I have in there? I have 4. 3 plus 5 is 8, plus 9 is 17, plus 7 is 24, right? That should be my answer. Just nod and smile. Right? Yeah, and so like I was saying, so what you might do here is like print n equals n, right? And if it hits here, well, actually that would be enough. So I'll just give you an example of how some people think about these things. So if I put in the same number, 2, 3, 4, 5, 6, or 2, 3, 4, 5, 8, 9, 7 is what I did, right? So it shows you how it found each odd number. See the thinking there? So if you wanted to kind of check your work, I'm just giving you an example. You don't have to do it that way. I'm just saying. All right, folks. That actually chews up the rest of our time. So when we come back next week, we'll finish up these exercises. It'll probably go a little bit faster, but I think you guys have enough information now to go home and be dangerous. So please try to solve them in advance if you can. Right? And then we'll proceed from there. So next week, we'll finish up the exercises and then another chapter. If you guys want to read ahead, please feel free. All right. Take care, you guys.